last section of chapter 4. This is it. It's called Triangles and Coordinate Proof. Now, you've talked about proof a little bit earlier. Remember we did side, 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 side angle, side, and all that kind of stuff. And we proved triangles congruent to each other. This is a little bit different, okay? This is called a coordinate proof. And you remember that word coordinate? Well, when we had an x and y axis, we had coordinates of points. So if I put a point here and I wanted to find the location of that point, let's say we went over 3 and up 2, then the coordinate of that point would have been 3, 2. So that's what we're talking about when we're talking about a coordinate. This is called a coordinate plane. But what we're going to do is we're going to put some triangles in this coordinate plane, and we're going to, first of all, we're going to learn how to place the triangles on the coordinate plane to do a coordinate proof. So at first you're going to say, where in the world are you going with this? Well, just bear with me and you will see where we're going to go with this. So let's make another x and y axis. And we have a set of guidelines. It's on page 301. It's at the very bottom. It's one of the key concept things. It's an old box. I just happened to type it in. Let's scooch this up a little bit, and I'm going to put it right there. All right, and then we're going to look at this. This is right on in your book on page 301. And what I want to do is I want to talk about this and see how we're going to label this thing. All right, let me get everything set up and ready. Okay, now I'm ready to go. What we want to do is let's look at these things. This is placing triangles on the coordinate plane. Here's my coordinate plane, and I want to put a triangle on here. Look, I could just put a triangle anywhere on this coordinate plane if I wanted to. All right, so there's a triangle on the coordinate plane. But for the stuff that we're going to do, we want to be a little bit more, I don't know, we just want to be a little bit more organized about it to make things a lot easier for us. So you're not going to understand really where we're going with this just yet. After we learn how to set this up on this coordinate plane, then we'll do a little proof and I'll show you where we're going with this. So just bear with me. First thing it says use the origin as a vertex, or center of the triangle. So the vertex is going to be really, really important here. Okay, so that needs to be part of our triangle. One of the vertices of our triangle should line up at that origin. Why? Because it's easy, all right? Because what's the coordinate of the origin? The coordinate is 0, 0. So that's a nice, easy place to use. And you'll know what I'm talking about a little bit later. It also says place at least one of the sides of the triangle on an axis. Could be either one of the axes, or it could be both of them. So let's do that. Let's put a side of our triangle. I'm going to draw a triangle on here. And let's put one of the sides right there. Let's drop it down a little bit. There we go. Okay, so that's going to be one of our sides of the triangle. And it says keep the triangle within the first quadrant if possible. Now, there are some situations where we're going to have the triangle in the first and second quadrant. But for the most part, we're going to try to keep everything in the first quadrant. Why do you like the first quadrant? Well, you like the first quadrant because it's all positive, okay? Most people like to deal with positive numbers and not negative numbers. So we'll keep everything in the first quadrant. So I could... let's do this. I'm going to make a triangle. I'm going to keep everything in the first quadrant. All right, so there is our setup. Let's see what else they tell us. They say use coordinates that make computations as simple as possible. So the coordinates of this triangle, I want them as easy as possible. I really don't want to deal with fractions if I don't have to. So I want to try to keep everything as simple as possible. So let's put some coordinates in here to see what's going on. What's this coordinate right here going to be? That's pretty much the most obvious one. It's at the origin, so what are the coordinates of the origin? It's 0, 0. So this point right here is at 0, 0. Let's name this coordinate right here. Now, I don't know how far over I went. This is not on graph paper. I wasn't able to count how far. I'm not really sure how far this is. But I do know how far I went up and down. In order, this coordinate right here, this point right here, I do know the up and down point, the y part of this coordinate, and that would be 0 because we went over a certain distance along this way and we went up 0. So what am I going to call that distance along here? You could call it A if you wanted to. There are some situations where you might want to call it 2A, and I'll show you why here. Sometimes you might want to call this 2A because sometimes this point right here is halfway between here and here. So if this point right there, okay, it's right over top of this halfway point, the midpoint, okay, if that was the midpoint right there. Sometimes it's nice to make this a 2a and not an a, because what's half of this? If I went from 0 to 2a, what's half of from 0 to 2a? It would be a. So I could actually write that as an a. What if I wrote this as an a? All right, watch this. Let's get rid of that. Let's get rid of that. What if I called this point A0 and I told you this was the midpoint, it was the halfway point? Then what would you have to make that point? You would have to make it 1/2 A or A over 2. Do you really want to deal with A over 2? No, I don't think so. I think it would be a lot easier dealing with just an A. So if I make this 2A and this is the halfway point, this would just be A. Now how far up did you go at this point? Right, actually, let's not use that point. Let's use this point up here. I shouldn't have done that. All right, so if the whole thing is 2a, from here to here is a, so that means that would be a. How far up did we go? Now, we don't really know. We don't know that we went up the same distance as we went across or anything like that. We don't know, so we'll just say it went up some arbitrary distance. We'll call that b. All right, so that point right there would be we went over a and we went up b. So this distance from here to here is b. All right, so that's kind of how we set things up. Now, you could have different triangles. You're not always going to be given the midpoint. Sometimes it'll be a right triangle. Sometimes it'll be obtuse. Sometimes it'll be equilateral. There's all kinds of different things that we could do here. But this is kind of like a basic general setup. Did this stuff work? Is the origin, is one of my vertices the origin? Absolutely, it's right there. Okay, that vertex is at the origin. Are one of the sides on the axis? Yeah, this side right here is on the axis itself. It's not like floating above it or to the left of it or anywhere else. It's not in between quadrants. Okay, so that works pretty well. Keep the triangle within the first quadrant if possible. Yep, we're in the first quadrant. Make the computations, or use the coordinates and make computations as easy, as simple as possible. So by making this a 2a, I was able to make this point a 1a because it was halfway across. Okay, hope that makes sense. Because what if this was like a 3? Then what would this be? This would be 3 over 2, or 1.5. It's a lot easier if this was a 4, right? And you took half of 4, which is 2. Or if it was a 6, half of 6 is 3. Then it makes the computations as simple as possible. So that's why we did that. All right, let's do an example. This doesn't really make a whole lot of sense on what we're trying to do until we actually do an example and we see how this works out. Okay, here's the first example. It's not really hard. It's not a whole lot different than what we just did before. If you notice, one of the vertices is on the origin. This time you have two sides that are actually on the axis. This side right here, BC, is on the x-axis. This side, AB, is on the y-axis. All they ask you to do is fill in the coordinates of these points right here. The easiest one would be this one right here, the origin. The origin is always at 0, 0. So I'll make that point 0, 0. That's really all they're asking for. Let's find the coordinates of this point. It's point C. So how far did I go over? Well, we don't really know. We could call it anything. You could use any letter you want. But in order to be a little bit more on the same page here, be a little consistent, let's say anytime we go over the x-axis, we'll use A's. Anytime we go up and down along the y-axis, we'll use B. So what was that length? If that whole length is A, then what would this point be right here? So for instance, if this was a 4, if the length of this was 4, what would this coordinate be? It would be 4, 0. Now we don't know it's 4, but we do know the length of it is some unknown number A. So what is the coordinate of that point? It would be A0. Now I know what I told you on the other one. I said sometimes it's better to put a 2A in here, and you could have done that if you wanted to, and it would still be right. It wouldn't be wrong. You could pretty much put anything in here. As long as you put a 0 for the Y part of this, you could be good to go. Now remember we said we're going to do here, let's make the length of the vertical, the Y, let's always call that B. So the length of this is B. It's not necessarily the same as the length down here, is it? This looks a little bit longer than this one does. I did that on purpose because I wanted to make sure that you knew that this length isn't always going to be the same length as this. Some people try to do that. Well, what's the coordinate of this point then? How did you get to this point? You started the origin, and then you went in the x direction, then the y direction. So you go 0 on the x direction, and you went this far on the y direction. How far was that? B. So the ordered pair would be 0, B. Again, for instance, let's say that B was a 7. If the length of AB, this thing right here, was 7, then what is the coordinate? It would be 0, 7. Well, we don't know it's 7 because I don't have any marks on here. I can't really count, but I did make the length of that called B, so that point would be 0, B. So that was basically a rehash of what we just talked about. Now we're going to do a for real proof, okay? One that we're going to use this in order to prove two things are equal to each other. Okay, here's what the proof's going to ask you to do. It's going to say write a coordinate proof to show, oh, there's the bell. No, it's not time to go yet. This happened in the last video. I'm actually at parent-teacher conference. I've got about an hour and a half before another parent comes in to talk to me, so I figured I'd get this last video finished for this chapter. So here we go. Write a coordinate proof to show that a line segment joining the midpoints of two sides of a triangle is parallel to the third side. I'm like, oh, what in the world's going on here? Well, let's take this just little piece by little piece, just in little chunks, okay? Write a coordinate proof. Okay, so you know we're going to do this whole thing, put a triangle on a proof. To show that a line segment joining the midpoints of two sides of a triangle. Let's start with a triangle first. It doesn't say any particular type of triangle, but remember what our coordinate proof thing is. We're going to have at least one of the vertices, or not at least, we're going to have one vertex at the origin, and we're going to make a triangle. Now, it doesn't have to be isosceles or anything like that, just any old triangle. It could be obtuse if you wanted it to be, but I'm going to make mine kind of look like this. And let's go about like that, and let's go about like that. All right, so there's a nice triangle. Notice what I did. I put one of the sides on the axis. Okay, I didn't just have it floating up here. It's all in the first quadrant. That's why I didn't even draw really the second, third, and fourth quadrants, because I knew everything was going to be in the first quadrant right here. And what we want to do is we want to show that a line segment that joins the midpoints of two sides of a triangle. Well, you can take any two sides. I'm going to take this side right here, and I'm going to take this side right here, and I'm going to join the midpoints to both of those. I'll do this in a different color. Actually, let's do it in red. Come over here. If that looks about where it would start, and if I join the midpoint of this one, and if I take it all the way over, watch where it hits, hopefully. Yep, look at that. It hits right where the midpoint. See how that comes together, and that would come straight down. So it hits the midpoint of that side. All right, so that's pretty important stuff right there. And let's put some coordinates in here. And what do I want to do? I want to show that this line is parallel to this line. That's what I want to do. And we'll get to that in just a second. All right, let's mark some stuff. Let's mark the origin here, which is 0, 0. Remember, we're hitting midpoint. So if you drop this straight down to here, and you drop this straight down to here, this point right here would be the halfway point between here and here, okay? And this point is the halfway point from here to here. All right, so if I put that in right there. So this is a midpoint right there, and this is a midpoint right there. So we're going to have to put some numbers in here. Remember what one of our rules said? It said make things as simple as possible. So that's what we're going to do. Okay, we're going to try to make it as simple as possible. So let's do this. Let's call this, yeah, I think we'll do it like they do it. We'll call this 2a. So what is the coordinate of this point? It's 2a, 0. Now, if this is 2a, then remember, this is the halfway point. Let's see, how should I say this? Let's go up to this right here. All right, let me see, hold on. Tell you, I looked it over and all that stuff that I just said, not all that stuff, but some of this, I'm gonna backtrack a little bit. Sorry about that, but you know, you live and learn. So what I'm gonna do is I'm gonna call this point something right there. Since we are talking about midpoints, I do want to have things where you can divide by 2. Well, there's Bell again. So what I'm going to do is call this point 2b. Now, we went over 2b, and then we went up, we'll call it 2c. Now, why do I keep using the 2's? Because I'm going to eventually find the midpoint, and it's a lot easier. I don't have to deal with half. If I make this 2 to begin with, and I take half of it, I'm just left with a b. If I take half of the 2c, I'm just left with a c. It makes it a lot better than saying this is b over 2, because I could have made this bc, but then the halfway point would be 1/2 b, or b over 2, and that's a little bit tougher to work with. It's a lot easier. Okay, this putting 2's here makes things a lot easier. And how do you know how to do that? Because when you work with midpoints, you know you're going to divide by 2, so you might as well start with a 2. So when you divide by it, It just makes things a lot easier. So let's figure out what this point right here is going to be. All right, I'm going to put the coordinates of this point. Remember, this is the midpoint, because remember we took the midpoint of this side. It's the midpoint of this segment right here. We could actually figure it out if we wanted to by the midpoint formula. Do you remember that formula? You add up the x's, divide by 2, then you add up the y's and divide by 2. Since this is 0, 0, it makes things very easy. 2b divided by 0. I'm sorry, 2b plus 0 divided by 2. So that would be 2b plus 0 is 2b over 2. So what's the coordinate of this point? It would be b, wouldn't it? Because if this is 2b, this is halfway in between, so this would be a b. Let's make this a little bigger so it's not all scrunched in there. So that would be b. And how far up did we go? Now, 2c is here, so this is 2c. We went halfway up. So what's halfway up? It would just be c. So 2c plus 0 divided by 2 is c. You understand? This is a lot easier now. Instead of b over 2 and c over 2, it's a lot easier to work with when you have that point just like that. Okay? Let's find this point right here. Let's do the same thing. We'll put the coordinates right here. And let's see, we went halfway. We went 2b, watch this, 2b plus 2a. I'm going to do this off to the side. Let's do it down here. Remember midpoint formula? So we add up 2b plus 2a, and we divide that by 2. 2 goes into both of those. Well, actually, we could do this. Watch, factor out of 2, divide by 2. That cancels out, and that's b plus a, or you could just say a plus b. So this point right here is a plus b. How did we get that? Remember, we knew it was the midpoint, didn't we? So how do you find the midpoint? You add up the 2, right? Because I went from here to here. I'm trying to find that midpoint. You add them up. You divide them by 2. All right, so 2a plus 2b divided by 2, and it's a plus b. How far up did you go? Well, you went up the same distance as you did over here. All right, so you went up the same distance, and that would be c. So that's your point right there. I'm going to erase this just to make this look a little nicer. Now, what are we trying to do? We've labeled all the stuff. Those are important points that we labeled right there. That's probably the hardest part of this whole thing, is just figuring out what to name the initial points. Then finding the midpoint wasn't that big of a deal. Now, this next part, it seems like it's hard, but it's really not that bad. So let's look. It joins the midpoints of the two sides, so we've joined the midpoints. We want to show that that segment right there is parallel, right? It's parallel to the third side, which is this right here. Now, how in the world do we show things parallel to each other? Or segments, lines? How do we show two lines parallel to each other, especially in a coordinate plane? Well, we would find the slope, okay? If I want to show that they're parallel, what must be true about the slopes? Find the slope, and if the slopes are what? Equal to each other, then the lines are parallel. So what I want to do is I want to find the slope of this line, find the slope of this line, and see if they are the same. If they're the same, then they're parallel to each other. All right, so let's give that a shot. How do I find the slope of this line? Well, here's the 2 points that make up that line. Do you remember what slope is? Slope is the change in y over the change in x. So let's plug some stuff in. So here's my 2 points. We'll call this the second point, and that's the first point. So it doesn't matter how you subtract. Let's do this way. Let's go this one minus this one. So it's a plus b. That's our y1, and this would be our y2 minus b. And that's going to be, so I took the first one minus the second one, or whatever order, doesn't matter. It's a little easier if you do it this way. And let's do the other one, c minus c. Oh, you know what I did? Wow. Hopefully you guys are screaming at me because I almost made a huge mistake right there. I just did the x's, didn't I? But it says the y's. I hope you caught me on that one. So let's try this one. Let's try the y's. Let's do it right this time. So we take the y's and we subtract them from each other. So it's going to be c minus c. Now we can subtract the x's from each other. So I'm going to go a plus b minus b. That's the change in y, and that's a change in x. I almost made a mistake that several of you guys make sometimes, and I'm doing the same thing. So at least I caught it. I got lucky. So what's c minus c? It's 0. What's this? A plus b minus b is 0, so it's a over, or 0 over a. What's 0 over a? It is 0. So the slope of this line right here is 0. You're probably looking at this and saying, well, of course it's 0. It's a horizontal line, Mr. Hammer. Can't you see that? Yeah, I knew that right away, but I wanted to do the math just to show you. Okay, that's part of doing the proof, is to show you that the slopes are the same. Let's do the slope for this one right here. Let's do the exact same thing. So I'm going to go y1 minus y2 over x1 minus x2. Remember, it doesn't matter what order you subtract them in, as long as you subtract the x's and the y's in the same order. So let me try to remember to do the y's first this time. Look at the y's. 0 minus 0. Well, that's pretty easy. And really, I don't even care what the bottom is, do I? As long as it's not a 0. So it's 2a minus 0. 2a minus 0. And what is that? That's 0 over 2a. What's 0 over anything? It's 0. And check it out. That's my proof. I just proved, see the slope of this line is 0 as well. I just proved that these two lines right here are parallel to each other because they have the same slope. And that is a coordinate plane. There's no statements, reasons, there's no two columns or anything like that. You just have to prove what they ask you by using this coordinate plane. So you find those particular points, those important points right here. All the vertices are important. Where the intersection of these lines, they were important to find. So once we find those points, then we can do what we need to do to answer their question. In this case, the question was, join the midpoints of two sides of a triangle. That's exactly what I did. I joined these two right here. Now you could have joined like the midpoint here to the midpoint here if you wanted to. All right, this made it a little bit easier. You could have, let's see what we did this one. You could have joined this midpoint with the midpoint down here and had a line like this, and then shown that these two lines were parallel to each other. You could have done it several different ways. I think I probably did it the easiest way. All right, well, I hope that makes sense. Again, these videos are just an introduction to this topic. If you look at this and say, oh my word, I have no idea what you were talking about, well, the next day that we have class, that's the time where we'll really get a lot of this stuff straightened out. So maybe we'll go over it again together in class. Maybe you kind of have a good idea and you just want to try some on your own. Maybe we'll do a couple proofs together while everybody's watching. So this is just an introduction to it. Just whet your appetite just a little bit, and then in class we'll really have a better understanding, hopefully, of how to do these coordinate proofs. All right, thanks for listening, and we'll see you the next day in class.